Hello Internet. Today we are going to be taking the mesh that we generated yesterday and we are going to be working on deforming it based on objects moving across it. So if you've played Tomb Raider, there is snow that if you walk on it, it depresses when you walk on it underneath your feet. We're going to be going for a similar effect, but we're going to be using the plane that we generated as the template or as the base for that. And then we're going to be manipulating the vertices on this to represent that effect. So I just stopped it. I don't know why I did that. This is what we have currently. It's a massive procedurally generated plane. I have 128 of these little squares per side, which is too many. That ends up being 128 squared. It's a lot of vertices. More than we want to deal with. So to fix that, we're actually going to bring this down to something a little bit more manageable. Good question what we're going to do. Let's do 16, see how that looks. So what we're going for is we're going for something that's dense enough that you can notice that it is, so it's dense enough that it obviously is being deformed, but we don't want it so dense that it's not really adding any value at that point. It's just becoming a mess. And this looks all right. We've got 8 quads or 8 rectangles, I guess. What am I saying? We have 8 columns and rows per meter, which that should be close-ish to what we want. And we can tweak it as we go along. So here's what we're going to do. We're going to add a sphere here. And I'm just going to drop that at the 0 position and shrink it down so it's about 1/10 of a meter wide. And I'm going to remove these wireframe stuff so we can actually see what we're doing. So we've got a 1/10 of a meter sphere here. And I'm actually going to lift it up off the ground. And the reason we're lifting it up is because that sphere is going to represent our depression in our mesh. And so what we need is we need some sort of deformable mesh, I think is what we'll call it. And so what we're going to do here is we are going to accept a mesh file. Well, there's 2 things we're going to do. First off, we are going to have a public float for maximum depression. And this is going to be the maximum amount that you can depress this deformable mesh. So if we put it to like 0.1, you can compress things down so you can shrink it down 0.1 meters. Then we're going to have 2 arrays of vector 3s. This is probably slow. It will be slow. Well, it'll take up a bunch of memory. It won't necessarily be slow. But this is going to be original vertices. And then we're going to have another one for the modified vertices. And so what's going to happen is this is going to hook into our generate plane mesh. That's not how that works. We want require component. There we go. And we want to require our plane mesh generator. And so the idea here is that these 2 components are going to work the same. Our generate plane mesh is what we worked on before. That's what's generated in our plane. We want this to accept that and then work with it. And so the idea is we've got this original vertices and modified vertices. These original vertices are going to come from this generated plane mesh. So we've got our start. We're going to actually, I think actually the best way to do this is not to do any of that. We're going to do 2 things. We're going to have a public void function called mesh regenerated. And so what this is going to do is it's going to notice that our mesh was regenerated. So we're going to stick something down here. And what do we want to call it? That won't work. Up here we have to do it. Send message mesh regenerated. And so now our deformable mesh is going to call this when this message gets passed. So every time we regenerate our mesh, in this case it's only the start, but we can expand that beyond that. So if we want to regenerate it for some weird reason, like reset things, this will allow us to hook into that, and then it will allow us to reset everything. So we're going to do a private plane mesh of our plane, sure. Right now I'm just requiring the plane mesh. We could abstract that away and actually only require some other kind of mesh. Actually, we could do a mesh filter here, and that would work. Granted, this algorithm we're working on is probably only going to work for... Yeah, I think it'll probably work best for planes. It might work for a few other things, but we're only going to be melting things down. We're not going to melt them in or anything like that. And so it might get a little bit hard if it's not a plane, but we could explore that later. I'm just going to write it for a plane and we'll build it from there. Let's get our component for our plane mesh. There we go. And now we need to take our plane and grab the mesh from that. So the original vertices and the modified vertices are going to be the same. The only difference is that we are going to actually want a new list here. And the reason we want that, we can create a new list pretty easily, I think. Does it not have the mesh? Okay. Yeah, we're going to need to expose that as well. So we're going to expose our mesh filter, which is kind of gross. We're not going to do that. Sorry. We're going to create a getter for our mesh, the actual mesh object. And we could actually just do it for the vertices. We don't necessarily need to do it for anything else. I'm going to actually just fully expose the mesh. So we've got the mesh there, and we'll create a getter. Return the filter.mesh. And so this way we can get the mesh of this object like so. From here, it shouldn't show up in the inspector because the inspector doesn't show properties, and that's what that was. So this will only show up here. We could expose it through a custom inspector if we needed to see it in there, but we don't, so it's fine. And so now that we've got that, we can take our vertices and do a to array on that. And so I believe this will just create a new array from this array. We'll know if it isn't because our things will just depress infinitely, and that will be bad. So now what do we need to do? Original vertices, we also need our modified vertices. And this is actually just going to be the same reference to the original vertices on the mesh. And so what this is going to do is, since these are both reference types, if we change this modified vertices, that's going to affect the vertices in our mesh, or it should. We can play around with that and see what happens. Actually, we can play around with that right now. So just to prove my point, if I take the fifth vertice in that new generated mesh and set it to be a vector3 dot, actually, let's just move it down. So we'll take its current position plus the vector3 dot down. So this will move it 1 meter down from its current position, which should be a lot. So if this works, that one should be significantly lower than all the other ones. And then it should be pretty easy to test this. All we need to do is grab our generated mesh, do our deformable mesh there. Grab our, well, we don't have anything to do there. The maximum depression isn't taken into account here, so it'll do whatever it feels like, and our thing didn't work. Shoot. That was sort of the plan. The plan is a failure. Oops. Huh. And just to prove my point here, that this should have worked, I'm going to switch this out. Like that. And I'm going to regenerate it. Ooh, still isn't working. Oh, don't turn into yesterday. That didn't go well at all. Why would this happen? Do I need to upload mesh data? I believe. Yeah. That's what we need. What's the argument? Mark no longer readable? What? False. Maybe? I don't know what that argument is for. Frees up system memory of mesh data when set to true. Oh, that's just a spelling error. Okay. So it's supposed to say mark no longer readable. We don't need that, I don't think. So there's two things I'm thinking of. If we replace the mesh, that could mean that it totally wipes it from memory if we say it's no longer readable. But it could affect the current mesh we're updating. So I think we'll have to play around with it and see what happens. And I may have to do some reading up on it to figure it out. Okay. This is getting confusing. Unless, did I not attach it? Hold on. No, I did. It's there. Okay. Not losing my mind. Not yet. It's going smoothly. I haven't made any progress, and I've already screwed everything up. That's fantastic. Okay. We are getting logs. So, something else is broken. Generate to the plane mesh, builds the whole thing. Then it replaces the mesh with the new one. And so, wondering, filter. I'm wondering if we may have wanted to use a shared mesh here. And so the reason I'm thinking that is because I believe these can be edited. Could be wrong. Nope. Wrong. Eek. Ah. Well then. Clearly, I should have done my research. So we've got, I'm going to go back to mesh because that doesn't appear to have changed anything, and it doesn't, changing things for the sake of changing things is probably a bad idea. So we've got our mesh, our vertices. We're saving both of those. Now we're changing that to the vector down. Sure, so that should be at 0, 0, and then just very down. And if we change this to that, and then We don't want to optimize it, but there are some other things that there are here. Upload mesh data. Combine meshes, don't need that. Mark dynamic. That's what I wanted. So we're going to get our plane dot mesh dot mark dynamic. Okay. So I don't think that changes the behavior at all. Yeah, that just makes it so that we can keep updating it. So that we want that, it just doesn't fix our problem. And neither does whatever the heck that was supposed to be. All right. Plane.mesh.something. This is the part where I look for things that sound interesting. Probably not going to find it. Okay, clear blend shapes. Don't need that. What does this do? I already looked at it. Does what I thought it did. Why? Why do you do this? I mean, so what I'm thinking is we could do this. We could set the vertices equal to the modified vertices by doing this. That's not how we want it. There we go. It's expecting a list. Erg. Here, this will be slow. This will be good. To list. There we go. That's the worst way I could have solved that. But just for demonstration purposes and my own curiosity, it should get us by. So this is actually going to physically go in and set the new position. So what we need to do is take this modified vertices of 5, do that, and then upload the mesh data like so. Now this is going to be slow, but as you can see, it actually worked, and we got this weird hole. The problem is we want that to happen better than that. And we don't want to have to do all of this. The issue we're going to run into is we really don't want to be doing something like this. We don't want to be resetting everything. I just want to say this vertex changed, so let's update that. Granted, you can't do that because so the way graphics are drawn is there is the GPU and there is the CPU. All of this code is happening on our CPU. All of the graphic bits, all of the drawing the actual stuff, all of this stuff is happening on the actual GPU. And so you have to actually get it from one to the other. And I don't think there's a way to do parts, which is why this is required. Which is part of the reason I didn't want it. Okay. So if we're going to have to do that, we are going to need to find the best way to set the vertices. And it wants us to use a list, which means these are wrong. So now our time complexity is going way up, or our space complexity is going to go a little bit up, and our time and everything else. But that's fine. We didn't need it to be that fantastic anyway. Let's see. Original vertices, modified vertices, those are still the same. We just want to list and to list. We don't need to do both of these like this, but well, actually we do, because they can't be the same reference, because if they are, then changing one will affect the other, and that's bad. And it's important to remember classes are object or reference types. So, or they're not reference types. They're just passed as references. So if you have a list and you store it in multiple variables, if you add it to one of those variables, it's going to show up in the other one. It's important to remember it happens the same way as it would in Java, but you can get into some weird things. So if we use the same reference here, our original would change with our modified, and we don't want that. So we've got our modified vertices. That's good. We'll keep this here just so we know that the updates are getting seen. And then let's do our modified vertices to list. We can remove that to list. And then upload the mesh data. Do I need that? I don't know if I do. Let's find out. So if we need it, what we'll see is, okay, we don't. Cool. So we can just keep that. And that's all we need. So now all we need is public void. What do we want to call it? We need something that's in add depression. Add a vector. Sure, that's good enough for me. Vector 3. And now we are going to get into some very fun math. So all of this can go out of there. We're not changing our mesh when we regenerate it. So there's no reason to update anything. That's just a waste of our time. But we do need to do that here. And so mesh depressed. And we're going to add our log back. We'll do mesh regenerated. Yeah. There we go. I can figure out how to spell it. Good. Now all we're doing is setting our vertices to our modified vertices. So all we need now is we need to actually modify these things. And so now we get to do really fun stuff. For each, that's not what we want. We actually want a for loop here. And the reason we want a for loop is because we're going to be pulling things out of our list and adding them back in. So if something changes, I believe vectors are structs. Yes, which means, so structs and classes are a little bit different than one another. A struct is going to be a value type, which means that every time you change something in it, it's going to create a full new instance of it, compared to a class, which is going to be reference based. So if you change a class like we were talking about, every reference to it is going to see that change. Every single time you create a new value or a new struct, everywhere you reference it, that's a new value. So every time you change it, that it's new. A struct is going to act more like an int or a float or any of those other types. So the best way to think of it is it's immutable. If you change it, you get a new reference to it. So since that's the way those are, we actually need to pull the entire vector out and then replace it with a new one, which means we need to know where it is in our list. So let's do over our modified vertices. That's not how we want to do that. Let's do over the count. We've got our I, and now we need to do some really fun stuff. Vector 3, actually, we'll store it in a var, and we'll say the world position. So keep in mind, all of these modified vertices, our current object is at 0, 0, or is at the origin in our world. That may not always be the case. And so we need to actually translate our mesh, which is always going to be centered around that origin pivot. We need to translate that into actual world space. So if it's rotated or anything like that, it'll work. Actually, let's keep it this way, and I'll show you how to do it, and then we'll go through and show you and show what the modification looks like. It's going to require some matrix math, which isn't hard in Unity. You just have to know to do it. So we have our modified vertices. What we want to do is have a depression point, a float of a radius, and that should be it. So what we want is if something is inside of this point, we want to move it out of it. So how do we do this? Best way is just calculate the distance. So distance is going to be equal to our depression point minus our modified vertices at the ith position. And you want to get the magnitude there. And the magnitude is just going to be our distance. So we've got that. Now we need to see if the distance is less than the radius. Then we need to do something. Let's just move it down. For now, actually, let's not do anything crazy. Let's do the new vert is going to be equal to the original vertices position at the same position. So since we're using indexes and these are the same list, or we're the same list, these indexes should match up to, so the same vertices should be at the same index in both arrays. And if that becomes screwed up, then none of this is going to work. So you can take this and subtract vector 3 down times the maximum depression. And this isn't how we're going to end up doing it. We're going to have some fun smoothing stuff to smooth it out a bit, but this should work for now. So we've got that. Now we need to swap it into our list, which is going to be, that's not right, to our modified vertice, and I don't think it has a replace. Swap. Nope. Okay, we're going to have to do it ourselves. So we're going to remove at the index, and we're going to insert at our new vert. And the index is going to be I, but I think that's wrong. I want to check this quick. Can't check it because there's no documentation. That's good. I like that. There's an insert. Huh. Okay. We'll test this. We'll know if it's wrong because it will be in the, everything will get screwed up. But if we think through this, if we remove the, I think it's I minus 1. But that can't be right. Nope. We're going to do I. I sounds good. We're going to do I. I think that's correct. If it's not correct, then oops. And we're not going to see any changes because I'm not sending any changes. We need to actually add depression. And that's going to be called by other things. So we need another script that we're going to attach to our ball, which is going to find this mesh and actually inform it that we're changing things. So ideally what you do is you would actually attach, let's actually do that. So we have a mesh collider on our plane, or we could. So what we can do is if I do a physics deformer, and so we want a void on, do we want a trigger enter? Do we want to do triggers, or do we want on collision? On collision stay, I believe is what we want. That's going to be a collision with collision as the argument. And that should work. So, could be wrong, but we're going to go with it. And so what this is going to need is it's going to need a deformable mesh attached to it, which I'm actually not going to require this be attached to the same thing because they may not be. But public formable mesh. And we're going to just do formable mesh. Sure, why not? And so on collisions day, when that happens, we're going to do a collision dot something. Where did IntelliSense go? It disappeared and I would like it back. Still not there. What have I done? I guess we're going to make things up as we go. So we want the deformable mesh dot something. Don't know why this happens all the time. It's being weird. Add depression at the collision dot point. I want to say that's correct. We'll guess for now. And we'll give it a radius of 0.05 actually. And since we have our mesh or whatever, our ball being 0.1, this should work. This is mostly just for testing for now, but we're going to go with it and see what happens. So we've got a deformable mesh with depressions, should work. So all we need now is we need to actually drop the ball. But first, let's add, I'm going to add a plane here, a little bit below. Sure, 0.1. I think that'll work. And then we can do a physics. Let's just do a box collider. That'll work. And then I'm going to move it down 1, give it a size of 2 so it'll line up perfectly with that. And then just make it wide enough that our box will fit on it. All of this doesn't need to be precise by any means. We're just doing it to get it working. Errors. Does not have a point. It would be nice if I could see what it did have. All right. We're going to create a collision. This is really silly. Why am I having to do this? And it seems to be happening more and more. I think there's something wrong with my plugins or something for Visual Studio. Something's causing it to get really confused. So, what do we have here? Transform. We don't want the transform because that's going to be the object we hit and it's going to be at wherever that was. We don't want the collider. We want the contacts. So for each point of contact, we want to generate that. So for each contact in collision dot contacts, we are going to want to add a depression, right, of our contact dot point and a radius, which is 0.05. And then we just have to kill all of that with fire and bring it over here and plug everything back into our deformable mesh. And that should work. Cool. So now we should have an actually compiling program. Great. I'm going to do one more thing and add a rigid body to this. So our ball will just fall down and hit this sphere thingamajiggy, or the box. Then we're going to add a physics deformer onto that and stick a deformable mesh there. So this is going to reference that, which is in here. So theoretically, what we're expecting is when our ball hits our box, we should see a depression appear. And then we should be able to move the ball around and it should do things. Or not. Or I could be totally wrong. Mesh depressed. Doesn't look depressed. I think our radius may be a bit small. I'm gonna kick it up just so we can see what happens. It went up. That wasn't what I was expecting. Good news, it does work. Bad news, it went the wrong way. So our maximum depression is 1. So do we want a negative? No, we just want to actually depress things in the proper direction. Can't do that. So we're going to subtract. Oh, that was our issue. We're subtracting our down vector, which is just adding. So there we go. And we're going to add some down amount. And so when our ball hits it, it should move things. And now I can actually do some really fun stuff. I'm going to tilt this just a little bit towards our camera. I can actually move the ball up here. Where is it? Oh, there it is. So what should happen here is our ball should hit and roll down and then roll off. So we should get a nice line going through there. Which then I can... Eventually this value is going to become less hard-coded. But for now we're keeping it hard-coded just because it makes our job easier. And so what you can see is we're actually doing a pretty good job. We're cutting that, and our ball seems to have stopped. That's unfortunate, but it works-ish. I'm going to increase the grid size and try that again because it seemed a little bit wrong. As we do this, it's going to obviously break. Oh, I know what's happening. So we have a 3-dimensional difference that we're calculating. That doesn't really work for us. And the reason that doesn't work is because when we get this far down, we're out of the way. So there's a few ways we could do this. We could actually reduce this to 2D space, which I think is the correct solution. Is it the correct solution? Or is there a better one? This is a good question. No, I don't think that's the correct solution. Let's actually fix this the proper way. So you've kind of seen that doesn't work. That's wrong. I'm going to rotate this entire block, say 90 degrees. And then we can shift it over this way and over here. And that won't work because that's not centered. So just for total demonstration purposes, we're going to drop our ball again. Where did it go? Oh, we're still running. Shoot, my bad. Let's do that all again. I know, it's annoying, but anyway, bring this here, drop our ball on it, like so. And so our original mesh is going to appear somewhere over there. But you'll see, if we come over here, somewhere, we should see a depression, I think. I'm having trouble finding it. That's annoying. Okay, why? Why isn't it doing what I thought it would do? Now I'm concerned. Modified vertices. Those all look correct. We've got a lot of them. And Unity doesn't like it a bunch, but we can work with that. Huh. This is weird, actually. Unless... No, it's still inside of our space. So I would be expecting it to be depressing this because it's going to be referencing our actual vertices, not their world space vertices. And why it isn't is confusing me, because that leads me to believe that something is broken, which isn't a good thing. Unless that's the reason. I think we may have made that too small. 0.5. There we go. Okay. Lost my mind a bit. That's fine. Just to make sure everything's working, I'm going to drop it. Bang. We get that. Now, I'm going to move it off over that way. Bring it back in. And drop the ball. And the interesting thing we should see is our mesh still got deformed. And so the reason this is happening is because we're not in the proper space. Everything is operating in world coordinates except this. So there's two ways we could do this. We could translate our collision point to, we could translate all of our vertices into world space. Or we could translate this depression point into local space relative to this deformable mesh. And I think that's the best way, because that's one conversion compared to 4,000 or whatever. So let's do that. We've got our world pose, which is going to be using our current transform of the world to local matrix. And we want to multiply that by our depression point. And so this is going to take a world to local space translation matrix, which is part of the Unity transform object. You can go both ways. And so this is going to take the world coordinates and translate them to local space, and then we're multiplying our depression point by that. So this should be a 4x4 matrix, and it's going to have scale, position, and rotation all embedded in it some way. And then it's going to do a bunch of really cool linear algebra with that, and then we get our fun thing. It's a bunch of really fun math. We're not going to cover it because it's a lot of really fun math. So now we have this. If I drop this now, and we'll still get, oh, duh, I didn't actually finish what I was doing. We have our world position here. We need to calculate using the world position as our thing. And that's using a vector 4 dot xyz. No, dang. Okay. Shoot. Well, here's an easy way to do it. Build a vector 3 from a vector 4. Or not. I lied. World space 4. No. Ah! Ah! Somebody save me. I'm hitting all the buttons. World space 4. There we go. So there's our 4-dimensional world space. Now, what we want is we want to do our actual world position. There we go. And that's going to be a new vector 3 of our world position 4 dot x dot y and dot z. So we take those, plug it all in, it should all work. And then, huzzah, or not. So let's see what happens. We say we hit a collision, but our mesh is not deformed. So that's good. It means it's working. Just to really test this, I'm actually going to bring it back like so. Then we're going to do all of this fun stuff. So everything's back aligned the way it was. The only difference now is that it's actually rotated 180 degrees. So if our thing hadn't been doing what it was doing, you saw that the dot was appearing over here. We should see it appear underneath the ball. If it isn't, then our translation is wrong. Luckily, looks like we're correct. So everything's doing what we need it to. That's good. Now we need to do one last tiny little thing. And that's move this down. So we have our position. What we want is to actually change this calculation a little bit. So we're actually using, when we're calculating our distance, we don't want to use this modified vertices. We actually want to use the distance from the ground itself, because that's where your collision is going to be calculated. Which means we need to do vector 3 down times the maximum depression, which that's going to be super slow. And we can fix that in all sorts of fun ways. We could actually, we could fix that in all sorts of fun ways. We're not going to, mostly because time constraints, but it can happen. So, cool thing is, now it actually falls and hits the ground, which is what we want. Now, we just need to make it better. So, to do that, well, actually, we can actually do our ball rolling. So, going to take this, going to take our physics deformer. You've got our point. I'm going to make this public now so we can actually play with it. The collision radius 0.1 should be fine. Make it a float and plug it in here. It's just this one file that's being weird, but we can deal with that. And now let's just drop a bunch of spheres. Like that. It should be more than enough, I suspect. So we have a bunch of spheres. Now I'm going to take this and just slightly rotate it towards us, so they should all fall and then slowly roll off. So let's see what happens. And if they do, then our stuff is working. I'm going to go to the scene so we can see this happening. Oh, it's being a bit slow. This is what I was warning about. But we now have a bunch of these rivers of where they ran, which is sort of what we want. So I think that's probably a good place to leave it, and we can pick this up later, maybe, and maybe smooth this out a bit. So right now we're just depressing all the way down, and that gets us these really gross, like stretched bits, because our UVs and stuff aren't changing, and neither are our normals. So we're still getting some kind of weird behavior here. we can fix that. We're just not fixing it. So that's probably next up. And also we can smooth out these. Either way, this is where we're at now. And I think it's a good place to stop. So if you guys liked it, let me know in the comments and I will hope to read your comments. If there's anything else you guys want to see, leave those too. And I'm curious to see. But until then, see you, Internet.